So let's understand the question. Isomorphic string. So what is isomorphic string? So it is basically like you were given a two string. You have to tell it is isomorphic or not. How you can tell? Like every character in the string one should map with the exactly one character to the other string. Like what did I tell? Let's see in detail. Read this. Two strings are isomorphic if one-to-one mapping is possible for every character of the first string to every character of the second string. So let's see with the example. I am taking two example. One is A C A B and X C X Y. So what I am doing, I am just mapping the first like corresponding indexes. It should be mapped with the corresponding index. Like zeroth index should be mapped with the zeroth index of the other string. So what I am doing, A is mapping with X and C will be mapped here. C will be mapped with C. Like we can map with the same character. Uh, we can like it is a rule of isomorphic we can do. So similarly, I am mapping with A with X because there is X. So here what we can see every character is mapping with a single character. So it is isomorphic. But what if here it was V, then what you can see that A is mapping with X at the same time A is also mapping with V. So this violates the condition of isomorphic that it should be mapped with a single character. So it is not isomorphic. So let's go back to the question. So what question says given two string S and T determine if they are isomorphic. Okay, we have understand what is isomorphic. Okay, let two string S and T are isomorphic if their character in S can be replaced to get T. What does it mean? It says that like here E you can replace with any character, but you have to replace in such a way that after replacing it should get the same string as T. But the point is that you can't like the order where there is E present in the string S, you have to change with that character only. Like if there are two E present in the string S, at a different indexes. You can't change with a different character like one E you changes with A and the second E you changes with B. It is not rule of isomorphic. So you have to change the, both the character into the different character you want. So you have to do and if it changes to T then it is isomorphic. So the same thing it tells what is isomorphic. I just tell it is the same thing you can read. So let's see example and how we can approach to this problem. So what I will be doing, like if suppose it is isomorphic, like we have to find if it is isomorphic or not, but we are assuming that it is isomorphic. If it is isomorphic, like every character, like here suppose we are considering E, where there is E present at different indexes, it can be present. Suppose this string is very large and the E is present at different indexes. So there is a set of indexes where there is E present and there is indexes like we have to map E with A that we know for sure because in isomorphic we have to do like that only. So we have set of integer which represent the indexes where there is E present and we have set of integer which represent the indexes where A is present. This should be same. If it is not same, what does it mean? It means that E is having multiple character mapping. Why? Because if it is not same, then another character should be at that place and it should be mapping with E. So E is mapping with multiple characters, it means that this not isomorphism, and we will return at that point false. So let's see what I am trying to say. Like here, there is suppose a big string. There are many characters. At some place there is E. Suppose there is some character. Here it is present E and E is present here. And this is S. And for T, this is also a big length of string, but the length of both the string should be same. So suppose where there is C, I'm just writing the corresponding character. If here is E, suppose here character is D. Here is some character, here is D, and here suppose it came Y. So I am storing the indexes of E, means 0, suppose there is some indexes, so 0 to 5. And here we know that this should be mapped with this. So I have stored corresponding vector of this which represent where there is E present. I am also storing the vector which represent the indexes where there is D present. But here that is 0 and 2, and the 5 is not, and this vector is not same. What does it mean? There is a position in T where E is mapping to different character. It means E is mapping to D also, and E is mapping to Y also. So multiple mapping is not allowed. So this is not isomorphic. So this is what the logic I am using in the code. So I will be using the unordered map. Like for every character, I will be storing a set of integer which will represent the indexes where it is present. And I will be doing for both, for the string S and the T. And just checking the base case, like if the size of the S and T are different, they can't be isomorphic because there is one character you can't match with another character because there is no character in the other string. So I have to return at that point false. So what I am doing here, I am just storing the indexes corresponding the particular character. Like where there is E present, it will come here like E. So corresponding to E, that index will be stored. I am doing same thing for the both the character, and after doing it, so what I will do, we know that for sure it should be mapped with A. So I am running a loop from 0 to n for the first character of the both the string set of the integer which represent their corresponding indexes where they are present. Like E where there is present the string S, and A where there is present in T. So they should be same. If it is not same, this means there is mapping to the multiple character, which ultimately is not an isomorphic. So we have to return false. If it passes whole the loop, then we have to return true. So let's run the test cases. So it has passed the test cases. So let's submit. So we have successfully solved the problem. Thank you.